So the question is, for which of the values of m the area of the region bounded by the curve y equals to x minus x square and the line y equals to mx equals 9/2. Okay, so let's first find the point of intersection. So y equals to mx is equals to x minus x square. So this is mx equals to x minus x square. So I'll send x square and x to left hand side. It will become x square minus x plus mx equals to 0. So x plus m minus 1 into x square plus m minus 1 into x equals to 0. So for x there will be two values, x plus m minus 1 equals to 0. So either x equals to 0 and x equals to 1 minus m. So at these 2 points the curves are intersecting. So I need to solve to find the area. A equals to, area is already given is 9/2, but let us apply the formula. Area equals to integration of the first curve minus the second curve. That is, the limits are 0 to 1 minus m. So solving this, x minus x minus mx minus x square integration dA integral 0 to 1 minus m, which is equals to 1 minus m into x dx integral 0 to 1 minus m minus integral x square dx 0 to 1 minus m. So this will be equals to 1 minus m into x square by 2 and limits 0 to 1 minus m minus this will be x cube by 3 and the limits will be 0 to 1 minus m. So further solving, applying the limits, 1 minus m into 1 minus m whole square by 2. So minus this will be 1 minus m whole cube by 3. So this will become further 1 minus m whole cube by 2 minus 1 minus m whole cube by 3. So the LCM, if I take 1 minus m whole cube outside common, so this will be 1 by 2 minus 1 by 3. So that will be 1 by 6. So 1 minus m whole cube by 6. So then left hand side is 9/2. We already have this. So 9/2 is equals to 1 minus m whole cube by 6. So it gets cancelled here. So 1 minus m whole cube is equals to 27, where 1 minus m is equals to 27 cube root, which is equals to 3. So we have 1 minus m is equals to 3 and m is equals to 1 minus 3. M is equals to minus 2. The value of m is minus 2.